Good afternoon, everybody. Welcome. Welcome to the first real session of Ignite. Now, thank you. It's always fun to be in the first slot. Nobody knows if things work. Wi-Fi is still working. Demos might work. Well, ladies and gentlemen, I hope that you have enjoyed the announcements this morning. You have heard in those a little bit about some of the technologies that I will be referring to. And before I get to that point, let me do a quick introduction. Let me introduce also some of the additional materials that might help you learn about machine learning, data mining, and the tools that I will be discussing. And then we're gonna do some demos. So that's more or less the plan. And before I go any further, my name is Rafał Lukawiecki. I don't work for Microsoft. I have never worked for Microsoft, but I have worked with Microsoft for 26 years now. And in the last 10 of those 26 years, I had the great pleasure of specializing in an incredibly narrow and obscure area of business intelligence known as data mining. I started that 10 years ago, and I was about 14 years too early at that point. I think I'm kind of doing it now at the right time, especially as we have a new name, because of course data mining became machine learning, and that has greatly improved the success of every data miner I know, because for some reason people like this name more than the old one. All right, I'm getting a little bit ahead of myself. My email address, rafał@projectbotticelli.com, is at your disposal over there for questions that you don't mind getting answered a few weeks or months later. And @rafał.net is my Twitter hashtag if you would like to have your questions answered pretty much straight away. Indeed, I will be monitoring BRK3550, which I hope is the correct hashtag. If you tweet a question, I will definitely answer it today, maybe even during the session, if I remember to glance at my screen. Okay, so what have I really prepared for you over here? And really the subject matter of everything I've been doing in the last few years is a little bit of data science by using a combination of these three technologies. The Azure machine learning technology, R, and SQL Server analysis services data mining technology, which I have been using for just about 10 years. These three are very complementary to each other, and I think that together they offer a very unique toolkit to people like yourselves. And I really would like you to leave this session not using just one or two of those, but having a good look at all three of them, because that's what I do with my clients. This is what I find my clients seem to like. It definitely helps in my consulting, and it definitely helps in the quality of my projects. Now, I have only 1 hour and about 10 minutes or so, so unfortunately I will not be able to teach you everything I would like to teach you. So for that reason, I wanted to very briefly advertise that I had the first in the world hands-on in-depth training course on Azure machine learning, which I have written. And the very first one, after we announced, unfortunately sold out very quickly. So we have quickly scrambled up a few more dates. And with great pleasure, I can announce that I will be returning to this beautiful city in November to teach this class hands-on. In the meantime, you can also learn from me from my in-depth videos. I have more than 40 hours of content on a variety of subjects, of which about 11 hours are on data science, available from our company's website, projectbotticelli.com, where you can also download the PowerPoints to this presentation, as well as a PDF version of the slides, which I have used yesterday at the full-day pre-conference seminar on this subject. Also, you can grab a data set for learning data mining and machine learning, which is called Happy Cars Azure, if you want to repeat my demos. This data set, however, is only available, like some of the better content on our website, to paying members. So to help you with that, I have a special offer for all attendees of Ignite. By using code 50IGNITE2015 in the month of May, all of you can benefit from a $50 discount on our 3 and 12-month and group memberships. So if you would like to grab that data set, or if you'd like to learn with me, or indeed with my colleagues about multi-dimensional expressions from Chris Webb, or from Caramel Gunn about doing BI with Excel, or Marco Russo and Alberto Ferrari can teach you data analysis expressions. All of that is available for you by reading this offer. Enough marketing of myself. time to do something for data science. Number one question that I would like to answer is, why would you want to do it? This is a question I have been answering for a decade. So I have distilled the experience of everything I've done for my customers into these 6 points. Not all of them are yet as useful to all companies, but some of them work always. Number one, discover reasons why you have failed or succeeded in the past in something that is not clear to you. 2, understand your customers, better understand your products so you can design better products. Plan better future, forecast what will happen, not just because you have some intuition and a feeling, but actually forecast with some way of trusting the numbers, statistical meaningfulness of what will happen. Experiment. Experimentation will be the next big thing in business in about 5 years from now. Right now, it's still rare, except for some companies. Today, when a businessman or a businesswoman makes a decision, typically they use their intuition, primarily intuition, guided a little bit by data in the recent years. But that will change. In the next 5 years, you will see that increasingly businesses, before making a decision, will say, well, how about we try it out? We'll make a little experiment over here, we'll see what happens, and then they will look at the results of that experiment with a magnifying glass of data science to decide whether they should or should not go ahead with the proposed change. This will fundamentally shift the way business decisions are made, and you can already start on that path today if you are in the right type of a business by using the tools and the ideas that I'm talking about. Of course, like the rest of BI, data science helps you improve performance of your organization, so much so that you might want to build a business that is run on analytics. I'm not suggesting that every business should be run on analytics, but there are those who are. Look at Netflix. It's a very interesting company. Netflix don't own almost anything. They have no hardware because it's in the cloud. They don't own software because they pretty much open source everything they write. If you wanted to copy and paste a Netflix to create your Petflix, you could do it just by getting their source code, and they even helpfully tell you how to do it. So what do they own? They own the best analytics in predicting what you will want to watch. So much so that they are shaving off thousandths of a percentage point in how accurately they can predict things. And sure, they could do even better than that, but so far they are one of the best, if not the best, in this business. If you think about them, by the way, it's kind of interesting. Recently, they started applying data science even to write better scripts for some of the shows. Not many of you probably know that 2 of their runaway recent shows, including Breaking Bad, were formed using data science. Some of the plot twists were decided by analyzing what you will want to see the most, what will hook you in front of that screen for hours and hours and hours on end. So if you think that writing literature is entirely the pursuit of a literary artistic mind, well, slightly supplemented with data science nowadays, it seems. Okay, if you think about data science, there's one thing that bugs a lot of people. Why is it called a science? Let me tell you, it's very easy, because it's not just technology. It's a bit of engineering on data combined with an extremely important principle that humanity discovered a few hundred years ago called the scientific method of reasoning. When you look at the data, you reason from it based on principles that you hypothesize that something could or should happen. You experiment, look at the facts that the experiment provides, and through simple and very well understood path of logical reasoning, you arrive to one of 2 possible conclusions. One conclusion is that, I'm sorry, you have to reject your hypothesis. And the other conclusion is, very good, the gentleman over here is an expert. Now, you're kind of spoiled because someone say no. Or, yeah, right. So the gentleman correctly answered. The other alternative is that you fail to reject the hypothesis. Most people think that the alternative is that you accept, but you can never accept. You can never be sure. Oh, business people hate that so much. Can I be sure? No. So I can only tell you that I cannot reject that thing. Does it mean you accept? No, 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 no. So what do? You do it again. And if you haven't rejected it, you feel a bit better. And then you do it again, and again, and again, and again. And after you've done it sufficient number of times and you haven't rejected it, you feel really good, but you cannot be sure. Maybe that would be one of the best things for business, to realize that we can never ever be sure. And it's all about knowing how unsure is enough to do something. But anyway, I'm getting a little bit ahead. In terms of technology, data science is a combination of 4 things, which I have drawn with equal-sized circles, but they are not equal-sized. It's a bit of machine learning, data mining, a bit of statistics, a bit of big data technologies, and a bit of unglorified data wrangling, fighting with the data because the data is absolutely never in the right format. Can I be sure about it? No. But the uncertainty on that is just so small that it's almost like being sure. Except that, I cannot be sure by nature of my job. I cannot say yes, right? I can only say almost yes. 80%, on average, 80% of all projects I have done in the last 10 years, no matter whether it's governments where I help them with social protection, no matter whether it's retail, finance, insurance, doesn't matter. 80% of almost every of those projects is wasted by what some people would say, or spent, as others would say, on data wrangling. So really, if we were to draw these circles in size that is proportional to where the money goes, data mining, machine learning, small circle, statistics, small circle, big data, smaller circle. Big data is actually very small, but let's not get that. That's a different presentation. And a huge circle of data wrangling. And many people don't like that. They kind of feel like it's a waste, but it's not. Because really, data science happens as a process in which we are trying to better understand and change something in business through better understanding of data, which leads us to the ability to build better models, often predictive models, that help us change the business, which mean that the data will change again, and the models will have to be changed again, and as a result, the business changes, and it never, ever ends. I'll give you one example. Not my favorite types of projects, but for some reason I'm being asked to do them recently more than ever before, is fraud analytics. So business says, reduce fraud. Great. Show me data that has examples of fraud. Show me rows of transactions where you can, with your finger, point to this one and say, fraud, not fraud, not fraud, not fraud, not fraud, not fraud. I probably should say about 93 times. And then fraud again and again. No, 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 no. And fraud again. Now, if there is no such data, I cannot do anything. I have to find such data first. All right, so let's say you found this data. Great, 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 great. You have some fraud data. Now my worry is, can I build a model that predicts fraud based on everything that I can access ethically, morally, legally, and that I have access to? Let's say yes. Cool. Now I have a predictive model which predicts fraud. I can reduce fraud. Wow, that's great. What will happen? My model has to fail. Why? Because if I catch that fraud will disappear. And if there is no more of that fraud, then my model cannot work anymore. If I want to succeed, I must fail. As a result, I look for new data, and I build a new model. And great for consulting. Is machine learning the same thing as data mining? It's not equal. Now you are wondering, what is that funny symbol that I looked up? Strictly equivalent to, in case you were wondering. All right, it's not. Machine learning is used by data mining. Strictly speaking, data mining uses machine learning algorithms on flat data. But to be honest with you, I don't want to split hairs over this, and if you have a different opinion, that's okay. However, for practical purposes today, everybody who is using machine learning is doing data mining, and for practical purposes in the last 10 or 20 years, all data mining was using machine learning. However, data mining as a term is not as marketable anymore today because a few years ago, some companies that perhaps we could question their ethics and operations, etc., decided to use these technologies to learn so much about their customers that their customers almost lost entirely an understanding of what is privacy, not to mention perhaps even elements of liberty. But I'm not going to go there because, it's your election year, so I'll better shut up and I go. Europeans, you know what I'm talking about. Americans, I didn't say anything. All right. My point over here is that data mining as a term is not as marketable outside of this room as machine learning. When you say you're doing machine learning, people still smile. When you say you're doing data mining, they kind of look a little suspicious. So let's enjoy machine learning as a name for the next 5 years before that term also becomes less useful. What does it do? It helps you explore data by finding patterns, and optionally, you can predict. Predicting is also known as scoring, by the way. Everything in this field has at least 2 and typically 3 names because of the history of this area of the data science. So predicting and scoring is the same thing. Why predicting and scoring is optional? Because actually the most useful thing you can do is learn more. As I will show you in my first demo relatively soon, we will learn why some of my customers buy many cars from me. And just having that knowledge will be like, wow, wonderful moment. Sure, I could use my model to predict who will buy many cars from me, but I don't need to. I could have just stuck with the exploration and be happy about that. When you predict, which works very well, you can do a lot. You can create a more intelligent application, like using Azure ML, for example. But let me leave you just with one little warning. Be careful. Predicting the future is not so easy. Predicting the present is easier, and predicting the past is quite easy. And in case you are wondering why, let me tell you that predicting the past and present is very useful. Predicting the past, what happened? Was this a male or female shopper? Why did we fail? Did they like us? Or the present, is the customer happy now? Is this a fraudulent transaction? Actually, that's not quite predicting the present. It's predicting the present plus a few milliseconds into the future. Will this transaction defraud me in the next 15 milliseconds? So it is predicting the future, but it's so close to now, and so little can change, unless you are doing high-frequency trading, of course, which is a different matter. So little can change that we think of it as predicting the present, which is far easier than predicting the future. If you want to predict the future, I have an advanced course on predicting the future. But first, attend my predicting the present course, if you would be so kind. All right, tools. Would you like to know what are today the most popular tools for doing data science worldwide, and how much you should be paid as an employee if your title of your job is data scientist? That's a cool thing to share. Yeah, all right. Okay. With permission from O'Reilly Media, I am sharing with you this analysis of data scientist salaries this year, done very, very short time ago. And I'm pointing also with a few blue arrows to the things that I use. Now, I realize that those of you in the economy seats at the back of the room might not see it. So I have zoomed the top portion of this, so it's a little bit easier to read. And I'll come back in a moment to my arrows. So the first thing I want you to see, other than the fact that we use Windows and that SQL is the #1 data science tool, the amazing change from the previous year's study of exactly the same question is that Excel now became the 3rd tool in data science toolkit. We love to hate, and we hate to love Excel as data scientists. There is just no denying that it is an incredibly helpful tool, but with very ambivalent feelings people have about it, but we use it all the time. R is the star of the data science statistical show, almost entirely displacing from the importance the previous contender to that role. About 10 years ago, this whole area was started to a large extent by SAS Institute products, Unfortunately, those are now on the Gartner's 2014 October Magic Quadrant, the most likely to be discontinued in use BI technology by Gartner's 16% customers. And in between, you've got a little bit of everything else. And if you don't mind me zooming out of it again, I use, of course, SQL all the time. I absolutely adore using R wherever it is appropriate. I believe that Python, especially with the NumPy and SciPy libraries of numerical and scientific processing, are on their way up, and they will become as important, if maybe not even more important than R for some users. SQL Server, for the first time, is so high on this list in the data science survey. And I sometimes use Hadoop together with Mahout. I do not use Hadoop for any other purpose other than running the Mahout library of data science, machine learning algorithms. There are some very cool algorithms there, in particular one for collaborative filtering, which allows you to build interesting recommendation models. Okay. So that's what we use, and I hope you have already figured out how much you should be paid. Europeans, as a rule, take the salary shown over here, subtract approximately 22,000, and that's the European equivalent. Californians, take that number and just add 18,000 to it. No more to be said. As I already told you, my suggested approach is that you combine the technologies of SQL Server, Analysis Services, Data Mining, R, and Azure Machine Learning. And this is why you're getting a non-Microsoft guy to speak over here, because if you had a Microsoft guy, they would just give you only one of those things, whichever one is the priority. So don't worry, I'll talk about Azure ML a lot, but I want you to understand why the other two are so important too. Number one, SSAS data mining is easy, highly visual, intuitive, and it just works. It is my recommended technology for all of you who are new to this area because it tends to figure out what it is that you want to do. For example, if you don't know yet the difference between classification and regression, and you throw some data at it and say predict, it will look at it and say, he's looking at a number, I'm going to give him a regression. Or it looks, that looks like a discrete, I'm going to give him a classifier. And you don't need to know any of that. So it's kind of nice. It just works. R adds beautiful descriptive statistics that let you get to feel your data, and over 5,000 packages of anything that you could possibly analytically think. But you have to know what you are doing here. It is nowhere near as intuitive as SSAS. Whilst Azure ML's main benefits are that it's in the cloud, and I don't need to ask my customer to buy anything. Just swipe that credit card or get the free thing, and I can start working on it. And it costs next to nothing while you are still experimenting and figuring out your idea. And I know Microsoft like when I say that, but it really does. It can be like, $7 to $20 per month is the bill for a typical, while you are learning or you are experimenting, use of Azure ML. It has some very interesting algorithms. However, my main favorite two parts of Azure ML is that it automatically tunes itself and it removes the problem of throwing over the wall. What does that mean? I'm not sure whether it is called chucking over the wall or not in your country, but I understand that that has some special meaning, so I'm not going to go into that. Throwing over the wall is a well-known problem that a lot of my customers have. Some scientists, numerical analysts, blah, blah, whatever, create a model in their favorite tool, that could be Matplot, MATLAB, Mathematica, maybe they do it in R. And then nobody can use it because it's in a tool that doesn't scale, cannot be deployed. So what happens is now you take this model and you throw it over the wall to some programmers who are typically in another country, typically in a place with warmer and moister climates. And those will dissect your idea and rewrite it in C++, and that's what you deploy. And then they throw it back over the wall. So we run it now, and of course it's not what I wanted, it's not my model, there are bugs in it, and it's like, whose fault is it? It's the fault of the wall. We don't want the wall. So instead of having the wall, how about your clever, analytically minded data scientist, analytical, predictive guy or girl writes it in the tool in which you can deploy it into production, and it's all in one place. Microsoft are the first people to have done that. Or at least they are the first large people to have done that. That's definite. I think that is a wonderful aspect of Azure ML, and I like it so much for that purpose. I have clients who are using it just to avoid having to throw things over the wall. But Microsoft also has some other data science tools. Microsoft has Hadoop in the cloud. This is called HD Insight, and it's pretty able. It comes in different variants, including a Mahout library, which I use for machine learning purposes. Microsoft recently has also started letting you analyze fast and furious streaming data using Hadoop-based technology, but without the complexity of Hadoop. And they call it Azure Stream Analytics. And there are some sessions that you should attend on the subject tomorrow that will explain it in more detail. The beauty of Azure Stream Analytics is that you can incorporate it into your workflow together with Azure Machine Learning, together with Azure Data Factory that can feed data from other systems. It's like ETL, extract, transform, and load in the cloud. And the rest of Microsoft visualization and front-end analytics, and of course that is Power BI. Of Power BI, I extensively use Power Query and Power View. In particular, Power Query allows me to quickly cleanse and prepare the data before I mine it, before I build models on it. And finally, if you want to do all of this not in the cloud, but on-premise, Microsoft sells an appliance. Actually, they don't sell it. That's sold through HP, Dell, and a few other companies, which is called Analytics Platform System, and it comes Hadoop, and a few of the other things pre-installed. All right, let's talk about machine learning algorithms and the process, and then we're going to go into some demos. First of all, the process of machine learning, process which I will show you in my demo, starts by defining and initializing a model, training the model, which means feeding lots and lots of data that represents today's reality, and then ultra important model validation. If you don't validate the model, you are not allowed to use it. And I say to my customers, I have one customer who's using an invalid model. Well, no, I have a lot of customers who have invalid models, but they normally stop using it. But I have one customer who is using the invalid model, and it's been making decisions, this model, for about 2 years. And no one understands how it works because it's wrong. But the decisions are good for business. So they keep using it. And I'm not even going to go into that. But, you know, it's not supposed to be like that. So you are supposed to validate the model. How do you validate the model? Well, I don't have time to explain it in detail, but I will show you a very simple, in Azure ML, validation by using a scoring task which predicts known outcomes and compares the predictions to what is known. I will not show you how to k-fold and partition the model, but you can learn that from my website. However, one of the most important things you must do while you are building your early models is to visualize them. I don't want you to be building black boxes, at least not at the beginning. I don't want you to build a credit scoring system which, hello, can I have a credit card? No. Why? The neural network said no. Oh, this is fraud. We should put this guy in prison. Why? Computer says so. There were movies about that. And the amazing thing is that you can do that today. So I don't want you to do that. What I want you to do is what I do for my customers. This is fraudulent. Why? This is node number 57 in a tree because lives here, did that, has this job, went there, has that relation. That's the reason. I want your early models to be explanatory, please. And when you feel them and you know that they are good, maybe consider using black box approaches, which can be more accurate, but not if they are only a little bit better. When I work with my customers and I have a choice, give them a more accurate model or a slightly worse one, but one they can explain and understand, I will always leave the one that's slightly worse. I prefer that strongly, even if it's not as exciting as a black box. Then, if your model is valid, use it. Explore with it, learn, or deploy. Deploy means that you put it into production. And of course, this is where Azure ML shines with the web services. There has never been an easier way to deploy models into production. So now you have a model in production, making decisions, and everybody's happy, right? Warning, you must keep updating it because the reality of the world will change around you. And as it changes, your model will not just stop working. What will happen is it will slowly become worse and worse and eventually become stupid. And you need to catch the moment when it's so bad, but still useful, that you don't stop its use, but you can start improving it. So revalidation on an ongoing basis in this automation is absolutely critical for any deployed models. Needless to say, that's also something you can do in Azure ML. In terms of the algorithms, there are hundreds. I don't know most of them. I know quite a few. But all of them can be grouped into approximately 10 or 12 categories, of which approximately 4 are the kings and the queens of all algorithms. And those 4 categories are clustering, classifiers, regressions, and I put it in one category, some people put in 2, similarity detection and recommenders. Clustering is interesting because it tells you about how things group. It's also a good example of a category of algorithms known as unsupervised learning, which I'm not going to discuss at this point because it's not as necessary. Classifiers, however, are absolutely the kings of this. I will share with you that for every algorithm I have used and built in my career, classifiers accounted for easily more than 70% of applications. Classifiers are pretty much the most important ones. What do? They predict which class something belongs to. Fraud, not fraud. Or maybe fraud, not fraud, I don't know. Or how many cars will this customer buy? Not many, many, awfully many. Classifiers generally predict either 2 things or many things, which is why we call them 2-class classifiers or 3-class classifiers. Of these, 2-class classifiers are where you should start. They are very much the bread and butter. Regressions are like classifiers, but they don't predict. I apologize. Normally, I reserve this kind of fun and a reaction for demos, so hopefully I haven't run out of my demo karma. All right, there won't be a story because I've eaten the time for the story, so I'll just get on with it and tell you that regressions in themselves are often considered very similar to classifiers. The only difference is that regressions predict a number, such as how much profit will I generate from this customer, or what will be the age of the most likely person who wants to buy this type of a product. But this is very, very interesting because when you are predicting profit, you could ask a different question. And rather than saying, how much money will I generate, you could say, which income bracket will I generate? Or which profit bracket will I fall into? No longer are you then using a regression, but a classifier. And the difference between using regressions and classifiers is very, very, very soft. And you need to understand it, which is why I've got a training course about it. All right. Enough slideware. Let's get into some demos. I have 3 demos for you. Demo 1 is going to be in SSAS. Why? Because it's beautiful. Demo 2 will be in R. Why? Because you need to see it. And demo 3 will be in Azure ML. Why? Well, because that's what you paid your money for. So, with that in mind, this is the tool that fed me for about a decade. This is the place where my customers and everything have existed. I really like it. I mean, we have issues sometimes. You know, there are a few things that could be fixed, and it could be prettier. It's a little aging, but it still works very well. So, what am I going to show you in SQL Server Data Tools is that I have a few mining models created here that look at typical demographic information about potential customers of mine, actually in this case about my existing customers. In particular, I am building a model that looks at demographic information such as education, gender, home ownership, marital status, number, blah, 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 to predict, that's the outcome, the number of purchases the customer will make. And the number of purchases is not a continuous number, but a discrete number over here, which is why I am building effectively classifiers, except you don't need to know about it because SQL Server figures out what to give you depending on the data that you ask it to analyze. So let me show you the model. And just before I show you the model, maybe quickly I should show you the data on an example. So let me load some data in Excel. Actually, we're going to use this data set in a moment, so I'm just going to delete a column over here. Right, this is what the customers look like. Names, birth dates, marital statuses, income brackets, genders, number of children, children at home, education, occupation, and finally, I have information about whether they have a home and the commute distance that each of these customers has to travel to work. So this data has been fed through SQL Server Analysis Services Engine, and it created this model for me. It's very easy to create. It takes about 5 to 10 minutes to do so, and you can watch it in my free videos, which is why I'm not going to build it now, because I'd rather show you a bit more of something else. However, what I want to do with you is to interpret this model. And to do that, I'm going to show you over here that all of my customers have bought never more than 7 cars from me. In fact, you can see that only one customer bought 7 cars. Majority of my customers buy 2 cars, the blue customers, the red customers buy 1 car, the green customers buy 3 cars, and I absolutely adore purple and yellow customers because they buy 4 and 5 cars. Unfortunately, based on the data set I don't have so many customers who bought 5, 6, or 7 cars. So my boss says, well, let's be realistic, Rafael, and let's focus today our marketing efforts on purple people, because purple people buy 4 cars and we want to sell a lot of cars. What am I really talking about is customer lifetime analytics. That's the official name for it, all right? It's a complex name. So the easier thing is you basically count how many things people bought in their entire lifetime, and that's customer lifetime analytics, all right? So how do I find purple people? How do you find purple people? Well, you look at the tree, and the tree says, not so many purple, not so many purple, not so many purple, more purple, ooh, plenty of purple people. Can you see what makes a person more likely to be purple? Being rich, which is absolutely normal. You will find it whenever you are analyzing any retail data set. People who have large incomes tend to buy many things, therefore they are purple. So now my boss says, ooh, fantastic, except our marketing plan involves seeing everybody on this list and taking them out to a lavish restaurant. And unfortunately, I do not have enough money to send everybody who is so rich to a lavish restaurant, because those restaurants are very expensive, especially when people are as wealthy as that. And secondly, well, we don't have time to do it. So could you, Rafael, find amongst the rich people a group that is more likely to buy 4 cars than not? And of course, that's why it's called the decision tree, because on every level of this tree, potentially there is another level that shows you what is the next most important thing. And if I click this plus symbol, you will see what that thing is. But before I show you that, I want to show you a dependency network viewer, which shows all of the variables that matter. The most important variable, as you have already seen in that decision tree, is the yearly income, followed by total number of children, by commute distance, by education, occupation, and the number of children at home, with a midpoint being approximately where you probably should stop interpreting or over-interpreting the results. So if you think about it, you would probably be wise in suggesting that the next most important variable is the total number of children that the person has, because that appears as the second strongest link, right? But that's not the right answer, because that applies to everybody in my data set. But I am no longer looking at everybody. I am now looking only at people with incomes greater than 100,000. So that's the beauty of a decision tree. On every level, you gain intelligence specific to everything that got you to that point in the tree. So let's have a look. I want people who have a lot of money and who do not have too much education. All right? Now, let's be honest about it. This is not a completely real data set, okay? And I appreciate that you are laughing because we decided to make learning data science a bit more fun. So for that reason, we have placed 3 funny deviations from statistical normality in the data set for the pleasure of people who are using it. And anybody who finds it and contacts me will get a prize of free remote 15 minutes of consulting. If you look at this level, people with more reasonable incomes, you see that what matters to them the most is how many children they have. So let's follow this path. Let's say I have a person who has income of 25 to 50K, and they have more than 4 children. As you see, they are more likely to be blue than green. In other words, they are more likely to be 2 than 3 car buyers. What would be the next thing that matters to them the most? Well, let's see. If you have this income and 4 children, then what matters is how many of these children are at home. If you have more than 3 kids, or at least 3 kids at home, you are far more green than blue, meaning you are more likely to be buying 3 cars. And I'm sorry, but if most of your kids are already gone from home, you will be a 2-car lifetime buyer. And so on, and so on, and so on, and so on. That is my decision tree. And if you think this is a complex one, no, this is actually a pretty nice high-level decision tree and not a bad one to build. But can we trust it? Can we use it? Well, let's test it, shall we? Over here, using the mining accuracy chart viewer, with just 1 click to say that I'm interested in figuring out if this model works for 4 car buyers, I will build for you a so-called lift chart. And I will not explain it in great amount of detail, but I want you to see on this lift chart what very good models look like. When you get performance that looks like that, it's good. What does it mean? This is randomness. This is the worst model you could find. And this is ultimate and unattainable perfection model that always correctly guesses who buys 4 cars. And since approximately only 11% of my customers buy 4 cars, well, if I had the crystal ball Madame Zaza model, I would ask it, tell me who are the 4 car buyers, and after it tells me the 11% of people, it doesn't have to tell me anything more, because it identified everybody who will buy 4 cars. Sorry, I can't do that. I don't have a perfect model, but I can do better than randomness. Randomness means that if I want to identify 100% of 4 car buyers, I have to dine with 100% of people, which of course my boss says we don't have money for. However, look how good my models are. If I use my model, especially the green or the yellow one, the green one is a decision tree model. If I use the decision tree model and I dine with 20% of people it identifies, I will identify 80% of 4 car buyers. And this is very, very powerful. That difference between 50% and 80% is known as the lift. This is the lift of the model, the uplift of the model. And that is why this model should be trusted. Actually, before you say it should be trusted, there are other tests we would perform, but the big first hurdle is already over. Okay, so how about we actually use this model to make some predictions? Well, that's as easy as going to Excel, going to the data mining tab, and in case you don't have this tab in your Excel, that's because you haven't downloaded the free Microsoft data mining add-ins for Office 2013, or Office 2010, or Office 2007. All right, there's even an older version, but it never worked, so don't go that far back. All right, using the data mining tab and using the query button, I am connecting to my local SQL Server Analysis Services server that has a number of mining models. This is actually one we've been building during the pre-conference yesterday, but this is the one that you've been looking at a moment ago, so I'll select this model, and using that model and the data in the Excel spreadsheet and all of the columns that I have, I will say, please predict for me the number of purchases and call it predicted number of purchases. And as soon as I hit OK, next, and finish, 4,500 predictions later, there you go, I have a column which uses the model, which is trustworthy. I can now sort all data from largest to smallest, and I can select the first person, and I can scroll to wherever it starts being 3, so to about position 113, and from Morgan Lewis to Gerald Rubio, I have 113 dinner dates already pre-planned. Well, there you go. From 4,500 customers, the model predicted the most likely to buy. Does it mean that each and every one of them will buy 4 cars? No. How many of them will? That depends on the precision of the model. Precision is a measure of exactly how many of those hits will be real. But if you want to learn about precision, well, there are, as you can guess, courses that you could attend. Right. What we are going to do right now, however, is we are going to move into a tiny little bit of statistics with R and R Analytics, because I want to show you Microsoft's Revolution Analytics OpenR, which is kind of a mouthful because until recently it was another company which Microsoft bought recently. And I want to show you a decision tree in R, as well as how to figure out something important, which is whether occupation of a customer is important to the number of cars they buy. This is an example of descriptive statistics. You do not need to use machine learning for it, but you should do it before you make any further decisions about how your models operate. First things first, R is a language, interpreter of that language, and a rather awful integrated development environment that nobody really uses except for people who have created it. That's a punishment for them. There is a much better interface for using R, which is called RStudio, which comes from a non-profit company organization that has created a freemium version of it, basically free, or you can pay for support. And Microsoft recommends that you do use RStudio. The reason R is so big is because it has a ton of software, which is free, that solves almost every analytical statistical problem you can think of. However, you still need to have the R engine, and there are 4 that I want to mention. The first R engine, the purest and simplest and free, is from CRAN. CRAN is the repository of all R software. However, when you start using R, you will very quickly realize that there is a message that it likes to appear whenever you analyze normal-sized data sets, and the most popular message that you will see in R, if you use the free version, is out of memory. So how do we solve this problem? Well, we learn how to work with multiple cores, threads, memory in memory, or we use a slightly changed version of R that magically removes the out-of-memory message. And not just because the OK button clicks itself. It actually solves the problem, all right? And one of those companies that did it is called Revolution Analytics. And that's why Microsoft bought it, and that's why I have been using it for parallelism and performance. Or you use R, which is built into Azure ML, which solves this problem too. And a few other interesting problems. It's actually a fantastic environment for running R code. Or, as you have heard from Satya this morning in the keynote, R will come also built into SQL Server 2016. It will be in the engine, which hopefully will resolve the problem of slow ODBC downloads and uploads of data. So rather than talk about it, how about I give you your second demo? Actually, it's 2 demos in one. I will show you a little bit of descriptive statistics and decision trees in R, and then we are going to jump straight into Azure ML. So with that in mind, let me switch back to my demo machine, and I am going to launch myself into, of course, RStudio. RStudio looks like this. This is where you write code. This is where you see your data, and this is where you see the results. And you can see that I'm using Revolution R Open for this. And in case you want to use any other version of R, it's as easy as going into the options in RStudio and selecting a different one over here. As you see, I have 2 installed, the default standard R and the Revolution Analytics R Open. So the way you would normally work with R is you would type things in. Like, for example, you could type in library RODBC, and you guess what it will do. It loads the library that lets me talk now to my local SQL server that has the data. But because I don't have time to be typing things in, here on the history pane, I have the things already pre-typed. So what I'm going to do is I'm going to open the connection through ODBC to R Happy Cards, which is local on my server. And now I will do the R equivalent of select star from customers, at which point, if I look on the environment, it's no longer empty. I have my customers table over here. Click click on it, and look, it's exactly the same data that you've been seeing a little earlier. This is exactly the same data that we've been analyzing earlier, and that's what I'm going to show you in a moment in a decision tree and in something else that is even more exciting in a way to a decision tree. But in order to learn how to use R, I suggest you do not type everything in. Use another library called Rattle, which is also free. When you invoke Rattle, what happens is you get this, how should I put it, slightly retro user interface, but at least it's a GUI. You no longer have to type. You just click, 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 execute, click, 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 execute. So it's a great thing for learning how to use R because you no longer have to remember anything, which is great for people like me too, especially during demos. So what I'm going to do now is I'm going to load this data set. Sorry about that. I will load this data set of customers that I have just acquired through ODBC. Rattle is funny. Whenever you click on anything, you have to click execute. And you may think it's a bit weird, but there is a reason for it. I'll show you the reason in a moment. So I hit execute. Here's my data. Then just click a couple of things over here, and we are going to answer a very important question. And the question is, does profit generated really depend on the occupation of the person or not? So I go to execute, explore, and I ask to see the distribution of profit generated using a box plot. I hit execute again. I go back to the R window where I see the results. Let me zoom into them. And now you are looking at this and you're thinking, what are we looking at? Well, what you are looking at is one of the best ever visualizations of data. And may I say one that doesn't exist, unfortunately, in Excel, and I hope it will get there at some point. This is box plot. What is a box plot? Well, it's a visualization of where your data points are. Data points here are customers. And what it tells me is that 50% of my customers' profit ranges between approximately $6,000 and $17,000. Also, this is the median. And it tells me that the median profit generated for all of my customers is about $11,000. And this star is the mean. And it tells me that the average is slightly higher than the median. Remember, means and medians are different from each other. Median is the value where 50% is above and 50% is below, and the difference is important whenever you have a so-called skewed data set, like, for example, earning income in the United States, where you have an enormous amount of people who earn nothing and a tiny, tiny, tiny group which earns almost all the money that is made in your country. So for that reason, if you plotted that, you would see a line and a star, and that star would be like, wow, far away from the line. Which is more important, the line or the star? Depends who you are. All right? Okay. So looking at that, you will also see here that there is a line. And that line that goes from the bottom to the top is the range of normality. I don't have time to explain what is normality. So just accept that normal profits go from 1,000 to approximately 35,000, and every dot that you see here are the outliers. Look at that. With one glance of my eye, I know so much about my data. But it gets better, because I have broken this now down by the occupations. And it wouldn't even take a child to figure out that people with management occupation, which is these green guys over here, certainly generate more profit for me than people with clerical occupation. That's easy, right? But here, it's not so easy. Professionals and skilled manual. Is this difference meaningful? We have a problem, because you can see that some people with professional jobs generate less profit than some people with skilled manual, because the boxes overlap, right? But is that meaningful statistically? Well, I could teach you about standard deviations, confidence intervals, and p-values. And I would like to. But you paid a price for a ticket to a sold-out conference, so I owe you a simpler way to answer this question. If you look at this, can you see that those box plots have a little notch, a little thing on the side that's been eaten out? This is what you're looking for. Do the notches overlap? No. The difference is statistically meaningful. Wow, that's it? Yep. Or you could pay a statistician to spend a couple of days just, doing something. But that's it. Why? Because the size of the notch is related to the confidence interval at the specified p-value, which is related to the standard deviation of the data. But you don't need to know that. All you are looking for, notches don't overlap. Good. Notches overlap, problem. Notches don't overlap. I have statistically meaningful difference between incomes of people, sorry, between profits generated by people with professional and skilled manual occupations. I like box plots. I like looking at box plots of all data, every attribute, before I even go to machine learning. But I have to move on with my demos, so for that reason, I'm going to close that, and I'm going to show you that you could also use R and R Studio and Rattle to build a decision tree. And when I show it to you, you will understand why I like SQL Server data mining so much. Now, because I'm using R, I have to be really careful what I click on. So I'll try to, let me just make sure. I am going to be modeling the number of purchases, and I need to not look at names, and I must not look at profit generated, and let's just check. So what am I looking at? I'm looking at birthday, marital status, gender, total number of all right. Why? Because if you make a mistake, it's not like SQL. It will just do, after a long period of time, nothing, throw an error, or you will get meaningless results. However, I hope I've selected the right thing, so I hit execute, I go to model, look, over here I can build a decision tree. So I hit execute, and oh, it's not very beautiful, is it? Is it? Is it? Is it? I know there are people who think this is beautiful. They're statisticians. Right. Look at this. It has a root. It has nodes. First node, yearly income smaller. How many children do you have? It's a decision tree. And when you show it to statisticians, they say, yo, that's very nice. But when I show it to my customers, they say, you know what, Rafał, we really would much prefer if you would leave us one of those things, because not only we can like click on this and talk about something, but we also like doing this very much during presentations. Okay. All right. Okay, Microsoft will probably never hire me again after this. Now, you've done what I told you to do. You looked at the data, you did the box plots, you did the analytics, you have visualized the models using SSAS. Now you are ready to take it to the next level. Now you are ready to put it in the cloud and do all of this on big data. Well, that's where Azure Machine Learning, of course, comes into its best. It's called Azure Machine Learning because it's machine learning in Azure, all right? I could tell you what was the previous name of this product, but I'm not allowed to, but it was so much better than Azure Machine Learning. But I cannot tell you what it is. Maybe later, but maybe not, maybe not. There are Microsoft people in the room, so I'm a bit shy when I can't tell you too much. What is it about? Two things, experiments and web services. Experiments is building models just like we built in R, just like we built in SQL Server, but in a nicer, more modern way. Whilst web services are all about deploying the model so that it can be used by your applications, by websites, by devices, pretty much anything you want to add intelligence into. And there are two versions of it, the free version and the paid version. The free version is slower and smaller, but Microsoft guarantees that it will be always free, subject to terms and conditions, which can be amended with a 6-month notice. Whilst the paid version can be free too. And if you are new to Azure and you get a trial for 1 month, you get 1 month free trial of the paid version. And if that trial runs out, you can get educational one. And if that runs out, you can like sign up with Microsoft for MSDN and TechNet and whatnot, or just smile to Microsoft, and maybe you'll get the free version for a while. Eventually, you'll start paying. Eventually, we have to pay, But when you pay, it won't be a lot. It's going to be like between $7 and $20 per month while you are learning and doing stuff. When you deploy it, sure enough, that's when Microsoft earns money, because that's when you will be invoking the web service, and you will pay something like 20 cents for each 1,000 invocations and a few other fees. But it's still nothing compared to what my customers had to pay 10 years ago. I have never had a deployment of these technologies for less than $50,000 to $100,000 just to say hello. That's what it used to cost. Now it's like for 20, I can get started. It's absolutely incredible that it can be done this way. Ladies and gentlemen, take my advice. Unless you really mind, use the paid version than the free version, because the most precious thing is your time, and your time will be spent more wisely by having things run faster than slower. All right, enough talking. Time for my final demo, which will take me to the end of this session, which is, of course, The thing you already know. We're going to build the decision tree. To do what? Predict how many cars people buy. But we are going to do it now in Azure ML. You've seen it twice. You understand the decision tree. So it should be easy peasy. Just put a few things together. And hopefully, we will deploy it also as a web service. Right, Joe. Let's switch over to my machine. And I am going to very quickly show you that using the existing version of the Azure portal, in this place over here called Machine Learning, using the new button, this is where you create a workspace. And the workspace will contain all of your models and data that you upload to it, but please don't upload any data to it. I'll tell you in a moment why. I have two workspaces. This is the one that I actually use with customers, so unless I make a mistake, I'm not going to click on it, and this is my demo one. And since I go quite often over there, I also have links over here on which I click to get straight into what? Into my ML Studio. ML Studio is the main tool that you will be using while you are using Azure ML. This is the place where all of your experiments sit. This is where you can manage some aspects of the web services that you are deploying. This is where you can work with data sets, where you save your trained models. And this is also where you can invite other users to share the workspace with you on an all-or-nothing basis. So, with that in mind, we are going to create a completely new experiment. Before I do so, check out the gallery of experiments other people have created. There are hundreds and hundreds of experiments already there, some of them pretty cool. And check out Microsoft samples over here, which are also interesting. But in our case, we are going to create a blank experiment. And the purpose of this experiment will be to... what are we doing? We are going to do will buy 4 or more cars ignite. That's the name of the experiment. And the first thing I need to do is I need to explain to you that this is the canvas onto which you drop little boxes that come from here. And these boxes are called modules. They are not called tasks, but I can't remember that, so I call them tasks all the time, but they are supposed to be called modules. And one of those that we need to use right now is the reader. Why? Because I don't want you to be uploading data to an ML workspace. I want you to keep your data in a SQL Azure database, or in an Azure blob, or in a virtual server machine with SQL Server, or anything you want. Just don't upload the data sets. Why? Okay. You could go to new data set from local file and get any of these data sets here, but trust me, each of them has a problem. CSVs and TSVs don't carry the data type information with them, so numbers will look like strings, strings will become numbers, and you will have to constantly change them. And goodness forbid if you come from a country outside of US, is it a comma, is it a full stop, is it an apostrophe? Just don't do that TSV, CSV, all right? Text files, even worse. SVM, they're quite okay, but nobody uses them. Attribute relation file format, ARFFs, are very good, provided you export them from Weka and not from R. If you export them from R, they will not work properly, so don't use them. Zip files are good, but not so useful. Oh, R data, I like R. Maybe we should use R for data, right? Yeah, but you cannot use it for anything other than using it with R in Azure ML. Oh, surely there must be a box that converts R data into... No, there isn't. Okay? Just listen to what I said. And what I said is don't upload the data. Put the data where it belongs. And we have this thing called databases. And that's where we should keep data, all right? And if you don't like databases, put it in a NoSQL or this or that, whatever. But have it in the same region in which Azure ML is located. And since Azure ML has to be located today, as of today, in US South Central region, make sure that your Azure database is also in the South Central region. So I've got my data, happy cars, and now using this pane, I will connect to this SQL database on my server, and the database is called Happy Cars Azure, and you can download it if you decide to sign up from our website using Rafal as the user account. Now, I have one of two options, and I never remember which one. We'll see in a moment. And now we will write the query everybody always writes, select star from customers. All right. Well, this is already an experiment. I can run it. What will it do? It will read the data, check my password, which is why I'm doing it actually, but it will do also one other useful thing. It will read the names of the columns, the metadata, the data types. So I will not have to enter any names anymore throughout the rest of this experiment. And whew, I got my password right, which is a good thing. I will visualize right now the results for you, and look, it's exactly the same data that you've been looking at earlier. Actually, almost. I've added one column over here. In the data set, I had a column called number of purchases. In this SQL database, I have generated a new column called purchased 4 or more cars, which is true if somebody purchased 4 or more cars, otherwise it's false. Adding such columns has a name. It's called feature engineering. Right. Now you know what's feature engineering. What is feature engineering really is the most important part of what you will be doing as data scientists, machine learning people. Everything else is just technology, 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 pass the exam, learn it, it's easy. The hardest two things that you will be building is features, basically inventing columns like that you need to add into this flat rows of data, plus figuring out if a model is valid enough for use. Those are the two hardest things that you will have to do. So I've already done a little bit of feature engineering over here, and we have purchased 4 or more cars. Let me just show you one other cool thing over here. Oh, what is that little guy? This is Mr. Boxplot. You can click on Mr. Boxplot over here, and then when you look at profit generated column over here, and you scroll down, hey, Microsoft implemented a Boxplot. Almost as good as the one in R. No notches, and you know what, do we really have to say in scientific notation, but fair enough, version 1, it will get fixed at some point. All right. I can't go any more into that because they are recording this, and you know, all the managers from Microsoft will be watching. It's like, okay, we are not inviting him for the next 3 weeks. So beautiful, thank you for putting the Boxplot into Azure ML. I appreciate that. Now, with the reader, I have the data, and using this data, I don't want to use all of the columns for my model. I will only select the columns that make sense. And to do that, using the manipulation area, manipulation section, I will use the project columns module. What does it do? It selects columns. So why is it not called select columns? I don't know. That's why you click on column projector. No, you actually click on column selector. Fine. Okay, I really have to stop this. I really have to, because there's somebody from Microsoft in the front row. What are we going to be analyzing? We're going to be analyzing birth dates. We're going to be analyzing marital status, yearly income, gender, total number of children. We're going to be looking at a number of children at home. We're going to be looking at education, at occupation, at home ownership status, at the commute distance, and, of course, the predictable outcome, whether this person purchased 4 cars or more. All right, so I have selected my columns, and now, in order to build a model, I need not just to build it, but also to test it, because as I told you earlier, validation is critical before you can use any models. So what I will do is I will use the same trick that we use over and over and over again every time we are building machine learning data mining models. I will split this data set into 2. I will take 70% of the data and send it here on the left, and 30% for testing, randomly selected, will go on the right. Now, using this 70% of the data, I will train a classifier. So, under the machine learning section, you first initialize a model, then you train a model, then you score a model, and then you evaluate a model, which is why they are shown in alphabetical order. I will initialize a classifier, and this classifier that I want to use, who can help me? Is it a multi-class or a 2-class classifier? Will buy 4 cars or more, true, false? 2-class classifier. 2-class classifiers are also known as binary classifiers. Which one should I use? I'm going to use the simplest one, the 2-class boosted decision tree, because it's a nice, simple algorithm, and it's also an improvement on what SQL Server Analysis Services tree can do. How will I use it? I will use it by training that otherwise empty but initialized model using the train model module, which takes that algorithm, the untrained model, and the training data. And now it's saying, I need to know what am I looking for, because classifiers classify for an outcome. So I will tell it that what I'm trying to build is a model of how people purchase 4 cars or more. So At this point, I'm almost ready because I have a trained model, but I don't know if I could use it. So the penultimate step is to score the model. Remember, scoring is just mining speak for predicting. I will take my model, and using the model that was built from this data, I will try to predict the data that wasn't used for building the model. What a cool trick, because I know how many cars these people bought. So now all I need to do is to evaluate whether the predictions match what really happened. So using evaluate model, I will take those predictions and the data, and I will plot the results for you. So let me hit run. It will take about 1.5 minutes to process this in the cloud unless I made any mistakes, at which point I will have not a decision tree we can see, because unfortunately today Azure Machine Learning does not come with a visualizer, yet another reason to use SSAS for this purpose, or perhaps even R. However, I will have a high-performance model and its evaluation results. If I like the results of the evaluation, all I need to do is to deploy it into the cloud and start using it. And I have about 3 minutes to do that, which I think I should be able to do. As you can see, it's already scoring the model. It scored the model. It's actually now evaluating it. The evaluation results should appear in a moment. I will right-click at the bottom of the Evaluate Model module and visualize them as a curve. And the curve that you will see will be the lift chart that you have already seen earlier, as well as 2 other curves, which are known as ROC, or Receiver Operating Characteristic Curve, and a curve called Precision Recall curve. I explain both the ROC curves and the precision recall curves in my online as well as classroom-based training. However, since you already know lift chart, if I visualize that and I go straight to the lift chart, wow, how beautiful is that? I already told you that when it looks like this is good. This is good. Guys, girls, trust me, this is good. If you get data like this, worry that it's probably too good to be true, but in this case, it's actually quite good. Indeed, you could also look at the precision recall. Wow, that's a nice one. And a ROC curve, this is almost perfect. When you get results like that, this is good stuff. But it's not just about the curves. There is a ton of useful data over here that you ought to understand while you are balancing the precision or the recall of your model. Basically, it's like a metal detector. This metal detector, well, this one finds every terrorist, but it also beeps for everybody who goes through the metal detector. Whilst this one finds pretty much nobody, but it doesn't annoy people at all. So if you travel in the United States, that's about here. Frankfurt Airport would be here, Portugal here, and if you travel to South Africa, they're just happy people. They don't care about things like that. All right, deviating from that, I would like to now show you that this works. And in order to do that, we have just one final thing that we have to do. We need to publish this as a scoring experiment and as a web service. So you can simply click this button and it goes and it does a little bit of a song and dance and it moves things for you. Very nice, very nice. And at this point, we pretty much have the goods, right? Well, almost. At this point, you really need to delete this line and you need to make that line point over here and to click on this and to change a couple of columns, but it doesn't take a long time to get this going, because the most important part is that it already saved a trained model over here that we can deploy. Since I want to save you a little bit of time, I have done this little bit earlier, and I have saved a scoring experiment exactly like this one with the changes that we have made. And I am going to show you that this saved trained model can be now invoked using a test page. Using a page provided by Azure ML, I enter data for a lady, maybe no, a male. How about a single male who has not the highest income? I have to make sure it's entered exactly as in the original data. Has one child, not at home, bachelor's level of education, clerical occupation, not a homeowner, and lives very close to work. What do you think? Will this person buy 4 or more cars from me? Probably not, and we'll see the results as soon, and you are absolutely right. The answer is false with a probability of 6%. So I've tested the model. The last thing I need to do is, of course, to deploy it and use it in a real-world application. And to do that, I have already copied and pasted some of the code that is provided on a very helpful API page, which is available here, which you can copy and paste in C#, in Python, or in R, and I've already done it for you. So I will simply take it into my Visual Studio, which is running the Microsoft free Python tools for Visual Studio. But this time, we are going to pass data about a married female with high income, two kids at home. She's a manager with a home, and she lives quite far from work, but not too far. This data is simply encoded using JSON. We are invoking that endpoint in US South Central region, passing our API key. We wait synchronously for the answer, unpack it, and print it to the screen. Right, let's run it and let's see whether this female should be offered our maximum customer services and a huge discount as a likely buyer of 4 cars or more. The results came back, and when we scroll to the bottom and the end, you can see the answer is true. This lady indeed will buy 4 or more cars with a probability of 37.5%. Well, in just a few minutes, we have deployed a model that we have validated in 3 different technologies. I know that there is an awful lot of stuff that I could have told you that I haven't had a chance to. So if you wouldn't mind either looking up the stuff I've got for you on projectbotticelli.com or signing up to one of our courses, including the one coming to Chicago very soon, I strongly believe you will learn everything you need to start using Azure ML, SSAS, and R in practice. Now, just before you go, if you would be so kind to do me one favor, guys and girls, please evaluate this and every other session you attend at Ignite. 2 reasons. Reason number 1, your feedback is extremely important to us. I read every single comment you give me, and this is the reason we can come back to these events. So this is like your part of the job. However, in summary, I hope that in this session I have shown you that Azure ML is a cloud-based platform for production-ready machine intelligence. However, Microsoft Data Science Platform is much more than that, because it also includes other tools like HD Insight, Azure Stream Analytics, and a few others. And with that in mind, I want to wish you a lot of success with machine learning. Thank you very much.